Greetings, folks. Welcome. One of the main goals of data analysis is to summarize information and present it in a clear and concise way to others. Here's some information on a quantitative variable, which shows the amount of time that people wait in line to ride the Space Mountain roller coaster at Disney World. I'm presenting the data, but I really haven't done anything to summarize it in a way that's useful to others. In other words, this just simply isn't a very good example of data analysis. A nice first approach is to make a frequency distribution, which shows us the values that a variable can have and the frequency with which these values are observed. Here's a frequency distribution that summarizes this information. You can see classes of non-overlapping wait times and the percentage of observations that fall within each class. Also, I have a good descriptive title and show the sample size of 100 observations. Here's a review of the steps I followed to make this table. First, I came up with an appropriate number of classes. One approach to do this is to take the square root of the sample size. The sample size is 100 observations, so the square root is 10. So one option would be to use 10 classes. A second approach is to find the smallest value of k such that 2 raised to the kth power is greater than or equal to n. With a sample size of 100 observations, 7 is the smallest value that satisfies this. In other words, if you take 2 to the 7th power, it's greater than or equal to 100. The second step to making this histogram was deciding on the class size, which is the range of the variable divided by the number of classes. The maximum and minimum wait times are 120 and 10 minutes, which gives a range of 110 minutes. If you take that range of 110 minutes and let's just say divide it by 8 classes, remember one approach told us we could use 10 classes, the other approach said we could use 7, so we'll use 8. At any rate, if you take 110 divided by 8, it gives you a class size of 13.8 minutes. And why don't we just round that up to 15-minute classes, because often when we think about time, we think of it maybe in half hour or 15-minute intervals. I don't think anybody ever thinks of time in 13.8-minute intervals, or at least nobody that I know. The third step then is to set up equal-sized classes that are not overlapping. So the first class will be 10 to 24 minutes. The second class can be 25 to 39 minutes. The third class is 40 to 54 minutes, and so on. And then finally, we count the number of observations in each class. So here's the frequency distribution again, and I'll give it a serious B+ for displaying this quantitative variable. But to take your data analysis to the next level, you can turn your frequency distribution table into a picture. And the most common type of picture used to display a quantitative variable is a histogram. Here's a histogram that displays the distribution of Space Mountain wait times. It shows the values that the variable can have. In other words, the wait times range from 10 to 120 minutes, and it shows the frequency with which these values are observed. If you were to add together the percentages shown on the histogram, they would sum up to 100%. So there's 100% of the distribution falls within that picture. A histogram looks a lot like a bar chart, but there are no spaces between the bars. This is very important because the bars in a histogram do not represent distinct categories. Instead, the bars represent intervals along a continuous range. After you make a histogram, you should describe its shape, center, and spread. The two most common histogram shapes are symmetric and skewed. With a symmetric shape, the histogram looks like a mirror image. When a histogram is skewed to the right, it means that its tail extends far out to the right. An example of a variable that might be skewed to the right could be household incomes. That is, you have a few really high income households that are far out in the right tail. A left skewed histogram means that its left tail extends out farther. An example of a variable that is skewed to the left could be test scores, where most students get A's and a few students earn really low scores. So you have these few low scores in the left tail of the distribution. After describing a histogram shape, you move on to describe its center. For a histogram that is symmetric, the center is the bar in the middle of the histogram. For a histogram that is skewed, the center might get pulled a little bit in the direction toward the tail that is providing the skew. In a different video, we'll talk in more detail about descriptive statistics that we can use to characterize the center of a histogram. The third characteristic of a histogram worth noting is its spread. One measure of spread is a variable's range, which is the maximum minus the minimum. Another approach is to look at the histogram and find a range, say around the center of the distribution, that accounts for about 50% of the observations. In a different video, we'll talk in more detail about descriptive statistics that we can use to characterize the spread of a histogram. Here's a histogram showing the distribution of college attainment rates across U.S. metropolitan and micropolitan areas. So these would be regions, could be big cities like New York, could be smaller places like Bangor, Maine. So again, it kind of runs the whole spectrum. If I were describing this histogram, here's what I might write. The figure shows the distribution of college attainment rates for U.S. metro and micropolitan regions. The histogram is skewed to the right, with a center of about 20% of residents 25 and older having at least a college degree. College attainment rates range from 8% to 66% across the regions.